Today we'll be looking at objects, because you've probably realized once you try and have multiple versions of a similar or the same object moving on screen, it's a pain in the butt to code and it's not fun anymore. So now what we want to do is to come up with a way to do that better. So what we can do with this and look at it is we are going to separate out, similar to what we did last week with functions, where we took all of your code and organized it into nice, tidy, neat little functions, which made your draw loop much cleaner. A similar operation can happen now when you have an object that you want to put on screen. That object is much like that organized group of functions. But the method that we use in programming is referred to as a class. And a class is going to have four parts to it. The first is going to be its name. And then it has data that is part of the class. Then it will have a constructor. And then it will have methods or other functions that are associated with that class. So if we look at the original sketch where we had our setup function and our draw function, the setup function really is the constructor function of the main sketch. And then we have variables or data occurring at the beginning of it, and then the name of the file itself is the name. So this concept of encapsulating our lines of code into a class or an object is not really totally new. It's not totally, we're not beginning from scratch. This is something totally different. All it is organizing and distilling it down into a much more refined way of working. And once our car becomes a class, it makes it much, much more flexible. So I took an animated ball that I have in a different sketch, and I just took that class, attached it to a different project, and was able to then add that ball to the project by saying, here's my ball variable, and then I made a new ball, and then I can tell that ball to update and display itself, and I've now put that ball into my sketch and it runs. I didn't have to go through and type all the lines of code to make that whole thing happen. So it's a much more efficient way of working, and it makes your code much more portable. So you can take classes from one project and use them with another project and another project and another project. And if you start to really dive deeper and deeper into programming, you'll take a series of classes and organize those into a library, and then you'll be attaching that library to other projects so that you have access to all of the previous things that you've done, and it makes it much more dynamic and flexible. Now you can see on page 124 in your textbook there is a breakdown of how you would take and organize, like what we did last week where we broke it into a series of functions, and how you can port that into migrating the object into its own class. So there's a nice kind of two-column side-by-side comparison on page 124 in your book, and I would encourage you to go look at that and study that in a little bit more detail on your own. So once again, when we're working with a class, it has a name, and we start out, we just type the word class, and then we put the name of the class that we are trying to access. Then we list the variables that are going to be part of that class. So it's just like at the beginning of our previous projects where we would have all our variables listed before the setup function. So we have the name of the class, got a bunch of variables, and then we're going to have our constructor. Now, one convention to keep in mind is that classes will typically begin with a capital letter. That's part of the distinction of how we can determine where something is a class versus just a variable reference by starting the name with a capital letter. So that is a programming convention that you will see occur in many languages and styles of writing it. Now, it's not, if you used a lowercase, it wouldn't break it. But the convention, so that when you look at other people's code, or if someone else looks at your code, is that you use a capital letter in the name of your class. So we start out with the word class to tell the computer, hey, this is going to be a class. Then we have the name of it, curly brace, and then inside that we have our data, our constructor function, which then initializes all those values, and then our methods. Now, methods are simply functions. A method is a function. There's no difference between them, but when we're referring to a function within a object or within a class, it gets referred to as a method. So when we think, if you think in terms of an object, so if this were a car, well, then we could say drive, and the car could have a drive function, and the car could have a turn function, and the car, so we could have all of these. We could have a is the trunk open function. So then it beeps at the driver of the car and says, beep, beep, your trunk's open, and it gets the driver all grumpy and annoyed, but then they're appreciative that they didn't drive down the road with their trunk open. So we could put whatever methods. So methods are things that the class can do. They're just functions contained within it, but they are now tied to that. Now I've chosen to have an update function and a display function. The update function is where we update any position or state information or other things that need to be updated on this object. And display is where we then write the instructions of putting that object on screen. Now, I could call those other things, but I use update and display because then in all the objects that are visual objects that I will be using in all of my programs, I have an update function and a display function, and then I don't have to try and remember what they're called. I don't have to think about it. So I like to just use those as the names with all of my visual objects. I give them an update, I give them a display. So currently this car will have a width of 100, a height of 50. It's going to start its position at 400 x, 200 y. It gets a nice speed of 4, and then it will have some random color because I felt like having a little bit of randomness in my life. Updates its x position by the speed, and then if it hits the borders, it reverses its speed, so it bounces back and forth. So it's kind of a Pong style car, so it's bouncing back and forth. And then display just sets my fill color and draws it on screen. So to instantiate the car, we specify the variable type. Anytime we're using a variable, we have to specify what kind of variable it is. Then I give it my variable name, which is going to be it's whatever makes me happy at that given moment. Again, your variable name should probably be referencing, somehow explanatory to what object or data they're representing. And then to construct it, we say car1 equals new. So anytime we're using objects and referring to classes that you will construct, when you want that object to spring into existence, then you say new. So the word new is extremely powerful. So we say new car, and then my draw function tells my car then to update itself and tells it to display it. And when it's run, You'll see my nice pink car is bouncing back and forth. Back and forth. But the nice part is if I want a second one, now all I have to do is go car, and this is going to be of my V1 class. And I'm going to just let this one be a blue car because I want it to be blue. Oh wait, sorry, I can't. My cars are always, car version 1 will always be a random color because that's how that car class was constructed. So I can't change that yet. Just getting ahead of myself. So car 1B equals new car V1. And then all we have to do is say car 1B dot update. So if I had 100 cars, I would have car V1, car 1, car 2, car 3, blah, blah, up to 100. Then I would say, I want a new one, 100 of those. And then I would go through and have all 100. So I could do that, and it would work. But I'm just going to do 2 to prove the concept, because to do 100, I'm not really. Oh. I forgot, though, these cars are always showing up at the same. Forgot these cars are fixed except in their color. So technically we couldn't see the difference. So it really is time to move on to the next car. So I'm just going to hide that one for now. We'll come back to it. We'll make it a V2 car because the V2 is much better because it's the new car year model, and with the new model it's much better. So now I have a second class down here, my V2 class. Now if we look at the V2 class, it looks very similar to the V1 class. And it's got an X and a Y and a speed and a width and a height and a color. Now, my constructor line here on car V2 is a little bit different than the constructor on car V1. Car V1, it just has the constructor with parentheses. If we look at V2, it's now got some variables in there because it's possible when constructing an object to pass information to it about where or what or how you want it to be. So last week we looked a little bit at passing values into functions or arguments with functions. If you remember that part of the discussion, that part of your reading in the textbook, when you have an argument with a function, doesn't mean you're arguing with it. It means you're passing a parameter or a value to it. So when I construct this car, I can now specify where I want that car to be and how fast I want it to be. And we'll modify this V2 car this morning so that I can also pass a color in. So then when I make a new car, I can say specifically what color I want it to be, because that'd be more fun. Otherwise, we can see that the car is mostly the same. The only real difference is in my constructor line here, where I have these variables. Now, as the book rightly points out, when you construct a function where you are passing these values in, you have to say what kind of data type, and then you have to assign a temporary variable reference to it. And that's great. And in the beginning, you'll go, wow, this feels like I'm just like doing all kinds of extra typing for no real return on my value. but the reality is most class objects, as your programming gets more and more sophisticated and advanced, every time you construct an object, you will have half a dozen or more parameters that you are then passing into that object. So you say, I want this object to be here, I want it to have these qualities, I want it to look like this, I want it to use this image, and you pass all of that in, because you don't want all of that stuff hard-coded in the class. You want to be able to, when you make and say, I want this thing here, you want to be able to say what you want it to be, because its behavior is really kind of a little bit different from where and how you want it to be and look. And if you have 50 objects, it would be nice if all those 50 objects you could say, this one used this image as your graphic, and oh, this object used this image, this object used this image, because they're all going to move and behave in the same manner. You just want them to look different. So you can pass that in. You might give them then different speeds, so then they move according to what kind of thing they are. But now you're able to construct them using the same class without having to rewrite all of your lines of code. And that's where the real power will start to emerge. So right now,
Can I ask a quick question?
so car1 accepts no parameters, and even when I made a second car, we saw that one piled on top of the first one, but it's fixed because the car is fixed with its values. Now, if I just threw a bunch of randoms in there, okay, fine, then they would show up in different places, but it's not giving me a lot of finesse or control, because if I want to be able to specify exactly where I want those cars to be and how I want them to look, that's not going to work really well. But if we use my V2 car, I can now specify I want it to be at start at 200x, 400y, and have a speed of 10. So if I run this, oh, and I forgot. I created the object, so technically the object exists, but I never told the object to update or display itself, so I never got to actually see it on screen. So I also need to do a car3.update. car3.display. So now if I tell the car to update and display itself and run it, we'll see car1 and car3 moving on screen. If I wanted another one, car4, so we can just instantiate it. So it's a new instance of V2. So every object we make is an instance of that class. It's like a copy of that class with whatever qualities we want to imbue it with. So if we put this one up high, we'll start this one at 2020, and this one's going to be a super pokey car. It gets a speed of 1. So this is a very slow car. So you may be noticing that we're starting to get very redundant with the code of either within the constructor making the objects, or more so in the draw loop, where we have to tell each object to update and display. So you may start to realize that there's probably going to be a better way to do this. Anytime we have major redundancies in the code, we need to look to ways to further optimize that. Thank you. Let's try again. And now we see the pokey pink car up top. So currently my cars are all designated by their random color. But if we decide that, well, it would be nice to be able to not only specify where the car is, how fast the car moves, I even want to specify what color the car is. Well, we can just add that as a parameter into the class. So if I go into V2 here and look at it, currently I'm sending an X, I'm sending a Y, I'm sending my speed, but I will send in a color. So I will say color temp C. So I'm using the word temp up here because these are values that I'm passing in, but after this constructor line, because you may be thinking, it's like, well, if I send in this X or this Y, I would have access to it. But the only place in my code where I am aware of what those values were when they get passed in is in my constructor function, so between the curly braces of that constructor. That's the only place I have access to those values I've passed in, which is why then I have to assign them to variables that exist outside of that function. So remember that if you define a variable within a function, it exists in that function. So if I say var, wrong language. If I said int my x equals 10 within this function, the only function that would have access to my x would be that function. So I need to have these variables here outside of that function. So I'm going to take this color line here, get rid of the random, and then just go temp C. So now my color is equal to whatever color I pass in. So when I make my cars, I can just simply go color. If I want my car 3, the fast one, this one I'll make red because it's going fast, so it's my sports car, it's got to be red. So we'll pass in that, and my slow one is going to be, I'm guessing on my color here, hoping I get a lightish blue. We'll find out. I think I need to have a little bit more on red, but we'll see. Yep, okay, it's a little bit gray. So we got the red sports car on the bottom, but then the top one where I passed in the speed of 1, I ended up with a gray tone. Not quite what I wanted, but it works. So I could keep adding cars and adding cars and adding cars. So theoretically, for your 100 object animation homework, this would work, but it would be a tremendous amount of work because you would have object 1 update, object 1 display, object 2 update, object 2 display, and yeah, that would get really tedious and time consuming. But you could, but it's probably not the best practice to go into. So we declare our variable of the class name that we're using. Then we take that variable and say it's equal to new, that class name, and attach whatever parameters, if there are any. Where car v1 doesn't have any parameters, but also notice car v1 isn't very flexible because it makes the object, that's great, but I can't make my next one different and have any control over it, and I can't make of the car v1, I really can't make them all unique and different because they're fixed. The only thing that I could do would be to, say, assign a bunch of random values, but that doesn't give me a lot of control. And we saw with 100,000 objects that if you do it all based on random, you really do lose control and you get some weird anomalies that occur in it, which can be kind of amusing at times. But in the real world, that can be troubling because your client will get really annoyed if you get weird anomalies showing up and they didn't want them in the project. So a class is constructed of 4 parts, comprised of 4 parts, because we'll use constructed in a moment. We have a name, class, and then we list the name. Then we do our curly brace. Then we have the global variables that are part of that class, the data, and those values then are going to be unique to that object. So that instance of that object will be separate and different from any other instances that are derived from this class. So we have name, data, the constructor function, where we then say the class name and no parameters, or if we have parameters, we put the parameters in. Then we set everything up. So the constructor function is very much like your setup function that we used before. Then you have update, or then you have your methods, which in this case I'm using update and display. It's possible you could have other ones. Perhaps you have a check collisions method, so you can ask this object, hey, are you colliding with other objects, and you can pass the object in that you're in question about. So you can say, hey, are you hitting this object? And it can now check and see. So the parameters you pass in to functions do not have to just be ints and floats and strings. It can actually be other objects. And we will be using that in some of our later projects where we will be trying to find out, is object 1 interacting with object 2? So we will pass objects in as a parameter or an argument. But that's the real, I mean, what classes really do is they help you to further organize your code and remove the redundancies from your code. But they shouldn't be viewed as this, oh my gosh, this is so different than all of the other lines of code I've typed in so far. It's just a better organization, and then it allows you to be more flexible with it down the road. So then when you add in multiple objects, and the more parameters you put on the object when you construct it, the more useful the class can become, because that gives you more opportunity to decide what this instance of this object should do. So you don't have to write 10 classes for 10 objects that are virtually identical, because it would be silly if each one of these cars had a picture graphic associated with it, and you said, oh, well, I have 10 cars, so I need 10 classes because each one will have a different picture. But if they all behave the same and move the same and do everything, and all that differs is their picture, it would make sense to then just pass in a path name to where that picture file is as part of your constructor argument. So don't be intimidated by using classes. Don't be afraid of using classes. And know that the more you start using them, the happier your programming is going to become, because it will become flexible and reusable. You will find that you'll start building classes, and then you'll be using them, classes that you build on one project, you'll go and migrate a copy of that over to the next project you're working on, and the next project, and the next project. And it can make everything you do much, much easier and much faster. So getting this to work, first we're going to just create a basic sketch and get some movement going on screen, get it bouncing. Then after we have accomplished that, then we're going to move into organizing it into logical functions. Once we have logical functions, we're going to separate it into a series of, or into a single class, and then we will add multiple objects on screen with that. So beginning with it first, so all the standard stuff, I'm just going to do a 500 by 500 document here, and if we look at some of the other things, we will want to have our basic background. So it's always good just get some of the standard business stuff out of the way that you need out of the way in the beginning. Now I'm going to prompt it where I will hard code in the values of my objects, and I could just draw an ellipse on screen, then go back and create my x and y variables, but I know, since we know this is what we are going to do, I'll have my x, I'll have my y, and I'll start my y at 100, so the ball will be starting on screen. And I'm going to have a speed y versus just speed because it's theoretically possible we will want the ball to kind of bounce across the screen at some future point. So I'm just going to decide right now in the beginning that I'll have a speed y because at some point we will want a speed x, or we will be using a speed x in our equation. So we could even just put that in now even though we won't be using it. Now if you notice here, I'm adding numbers into my variables as I am defining them. We will be migrating that away from that because it's better to define values on variables inside a function versus defining them their kind of whatever their data value is. We create the variable, but we don't give it a value until inside a function. That is a better practice to be working with. And now because our ball is going to be falling, it's going to be affected by gravity. I could just use g or grav if I want, to make it a little bit more understandable. Now, depending on how strong you want your gravity to be, often I find fractional amounts work, but we could do it with whole numbers. If we did all of this with whole numbers, it's really fast, speedy animation. It falls super fast, so it does work better using floats and using a fractional value for gravity on this. So now that I have this, we can even just go through and say ellipse x comma y comma, and then I just need to give it the width and height. I'll give it a width and height of 20. Now that draws my ellipse. So if I run my sketch now, we should see, get a circle. It's not falling yet because we haven't made anything updatable. We're not changing any of the properties of the object. So right now it's just fixed on screen. So if we want this to fall, what would make sense is to then put some code in that modifies it. So if we were to say something like, so eventually we will use y plus equals speed y, which currently, if I run this, I will still get the same end result of its part because speed y isn't changing yet. So we do need to put in something that causes speed y to update. So now y is being updated by speed y, but speed y isn't being changed yet, so it would make sense to do that on the line above, and we could say speed y plus equals gravity. So we modify speed y by gravity. So the first time through, it becomes speed y was 0, it becomes 0.8. The next time it will be 0.8 plus an additional 0.8, so it'd be 1.6. And then it becomes 2.4. And as you can see, that means our speed y is going to keep increasing and keep increasing and keep increasing. And currently we do not have a speed limit, so we're going to see some pretty fun things happen
Okay,
here.
now the thing will just drop off the screen.
Gone.
So now what we need to do.
So I need to modify it so my ball doesn't disappear forever at this point. So before we modify the position of the object, we can say if y is greater than, well, height, which is the full height of my sketch, and that would be then the position of the ball, but we need to subtract the radius of it. So if it, because otherwise it will go halfway off screen. So now we can say if the height is greater than 20, then speed y times equals -1. Reversing the speed. Speed is equal to negative speed. Because speed when we're falling is a positive amount. So when speed so let's just say I was going at 10. So my speed y was 10 when I hit the ground. Well, it becomes -10 when I hit the ground. And then the next time through, I add gravity into it. So -10 becomes -9.2. And then the next time through, it becomes -8.4. And it keeps going up, and those numbers get smaller, and then I get to fall again. And if we run this,
It's going to get higher, higher, and higher, and higher until it gets off the page. Soon that ball's going to be blasting itself into orbit.
so we have now constructed a super ball. Because now the ball is going up and up and up at that point.
Now we need to constrain the height.
So a little reordering of the lines here, and we can do gravity, make it gravity less, gravity more, but we'll see that it progressively is starting to sink until we run into no man's land at the bottom. So I have a bunch of variables. I have a bunch of things that are tied to my object itself. We need to, if we so desire, clean up the object a little bit. We could put a speed limit in so it limits our maximum. So if we put in terminal velocity, so if we don't want objects falling super, super, super fast, we can modify that as well. And then we can also deal with when it gets to the bottom that if we're within a certain distance from the bottom and if the speed is at a certain value, then it's possible to then just make the speed become 0 and park the ball so that it doesn't disappear off screen. So there's a lot more we can put into it, but right now in the interest of time I think we will break this out because we can always add that in later. And that's not going to be the full focus of what we want to do, but it is something that if you decide you want to do cool physics simulations and all kinds of neat stuff that have, so you could create your own catapult system or your own Angry Birds style game and stuff like that that use physics as part of it. People that are wicked smart have built code libraries that all you have to do is just download the library, import the appropriate files into your project, and then you're able to take advantage of it. So you can do nice things like that. One of the popular ones that's used is called Box 2D, and that's a very popular one that you could construct your own version of Angry Birds using the Box 2D library, because that was what helped power it in the beginning when the first versions of that game were coming out. So right now, standard sketches we've done not organized nicely into functions, but if we want to start organizing into functions, and then we will work into organizing it into a class. So I'm going to separate this out. So my draw function is only going to call functions. Now we'll move clear background. Now it may seem overkill to have clear background into its own function, but if your draw function really does become just, it references other functions, this, instead of filling my background with white, I could fill it with transparent. I could do any number of other operations with it. So it really is something that it does make sense to start to separate things out as you go. And now I'm going to have an update function. My update function, the nice part about using it as update, when I put it into my class, it will be easy to access. So we move that and just say update. And my final function of display so my draw function calls the other functions. Clear background, update, and display. It's a more organized setup. The next step would be to now build our ball class that we're going to work with, and then we can put the ball into our project, and we can have a second ball and a third ball and a fourth ball as we see fit, which will be pretty nice. Now comes the fun part of organizing this into a class. So we're going to create a ball class. So I'm going to just give myself some extra lines at the bottom here so we can start up a little bit higher. So I begin a class by just typing the word class. And I will now type in the name of my class, and by convention, not by requirement, but by convention, we reference classes with a capital letter. And now I have my class. So I've created a ball class. It has nothing in it yet. It needs to have a constructor. It's going to need to have some data. It will need some methods. But currently, I have now assigned my name to it. So we will put in our, I will deviate from my previous comment about not putting in comments. And I will put that in because I'm doing a placeholder for my data. Then we will have our constructor where I simply say ball, and now I can specify what values we want to assign to the ball when we make it. So if I know that I want to feed into my ball a float for where I want it to be, so I can now construct my ball with at any position on screen. It makes sense to give it an X and a Y value. If I want to be able to specify its size, and I forgot, I want to reference these as tempx because these are temporary values that I will then assign to permanent or global values shortly.
You want to change those to capital letters then? No? Nope.
And I guess we could use caps in here just to make it easier to read. If I wanted to assign a color value, I could do that, but we'll just do our X and our Y and our size of it. Okay. So now I have my constructor line, constructor function, nothing in that, and then we will follow that by methods. At this point, what we need to do is to start grabbing stuff that we had up here and moving it into our class. But I have my basic class with name, and I'll just put a comment there. Class name, class data, class constructor, and class methods. So having these defined out, those are the 4 parts of a class. You'll notice a class, again, it begins with the word class. We have the name of the class, curly brace, and then we have our companion curly brace down at the end of it. Then data, we haven't put any in yet, but we will shortly. Then I will have my constructor line, and then the methods that we will migrate down as well. So at this point, all of these values were part of my ball, so it makes sense to go and grab those. So I can get those out of there. We don't need those up there. And we will add them to our class data. I do recommend that you maintain proper indentation and formatting of your code while you're doing this, because the more organized you are with that, the easier your code will be to read, and more importantly, the easier it will be to debug when you have errors and problems in your code. So we have some values that we will be assigning, and then some values that we are fixed, and we can go through and assign them as we need to. So X is going to be equal to temp X, Y is going to be equal to temp Y, and our previous ball didn't have a radius as part of it because it was just fixed. It was hard coded into it, but I'm going to put that in now. So now we're using those values that have been passed in. Temp X, temp Y, temp R, we're assigning those to the class data of X, Y, and R. So we can get rid of that there. So I have my data, I have my constructor, and now what I need to do is I need to now move down my methods. So my update and display that I had there are specific to this object. So there's no point in having them part of the main code. They should be part of this object. So I'll get them out of there, and I'll go put them inside my class. Whoa. Okay, getting a little fast there. So I'll put those methods in my class. So now I have update, I have display. I am going to change in my display function where it's referencing the radius value for my circle. I'm going to just change that to R as well as in the update. That's now made my code flexible to work with different sized objects instead of having the objects be the same. So now I can make different size balls as part of this. So I have my update, I have my display. They're now methods because, and it really, if you think about the logic, they're part of the ball. So the fact that they were in the main sketch is kind of like, well, the main sketch doesn't care about those, of knowing the details of those. When we start to think in terms of objects, think in terms of, it's kind of like a black box. It can do stuff, but you don't need to necessarily look inside. So it's like a car. Most people put a key in their car, unless they got a newfangled car where you just have to have the key with you, and then you push the start button or turn the key and it starts. You push the pedals, it goes. But if we ask most of you, but how does it actually work? How does that engine work? Why is it actually going faster when you press down on the gas pedal? What is the actual process that's going on inside the engine? We don't need to know that to be able to use it. We put the key in, turn the key, push the pedal, go. The ball is going to be the same way. That once you have the ball constructed, we don't really need to know how to use it. We'll just be able to tell the ball to update itself and tell the ball to display without having to know what's inside that, and it will just, it'll work. So the only thing really missing now at this point is we haven't made a new version of the ball to have access to, because we have a complete class. We have a name, it has data, it has a constructor, and it has methods, things it can do. Methods are what can this object do? What are the verbs of this object? Can it run? Can it jump? Can it fly? Can it roll? Can it? They're the verbs. So to use it, we can just simply say ball, reference the type of object I want, type of variable, ball1, now inside our setup function, ball1 is equal to new, and then we say a new what? Well, it's a ball. And then what are the properties of ball? Well, we can give it an X. I want my ball to be in the middle. I'll put it at 250. I want it to start at 100 on its vertical position. And I want my ball to be, let's give me a small one. Make it radius of 10. So I've now made a new ball. And if I want to see that ball, I can now just say ball1, run your update function, and ball1, run your display function. So I just tell it to update itself, tell it to display. Because the object won't do anything, because I can make as many objects as I want. But until I reference the methods of those objects, their capabilities, until I reference those, nothing happens. So now I can say ball1 update, ball1 display.
And that's a dot, ball, one and a dot.
That is a dot. We are using dot notation where we reference the object, dot, and then the method. And the method is a function. When we call a function, we always then finish with the parentheses. So as you can see, we didn't really add that much code. We've reorganized, but we haven't added that much. But for just doing one object, if you're just doing one object and putting it on screen, it really doesn't even make sense to build a class. But now that I have this class, I can make a ball 2 and a ball 3 and a ball 4 and a ball 5 and a ball 6 and tell them all to display and update. And I will have them all now doing their ballness of whatever they want to go do. So if I run this, let's see, I now have my bouncing ball. So it's the same as before, But, okay, well, if I want my ball to be big, what's nice about this is because the code now allows me to put that in. We're having a little issue at the bottom of the ball there. Is it using diameter, not radius? Ooh, that could explain a lot. There we go. Well, then it gets stuck. We still haven't solved that problem yet, but I have a bouncing ball. So if I want a second ball, I have ball 2. If I want that ball to start at a different position and to be smaller, and then we can just do ball 2 dot update, ball 2 dot display. And I could add as many objects as I had patience for. But we do run into that little issue when we get close to the bottom because we're not doing full checking on everything yet. As the speed diminishes, we're not able to escape gravity, and we get sucked into the gravity well of the planet itself. That's actually, essentially what is going on, which is why it gets stuck, because it moves and is trapped.
Let's have the bump up the speed by times minus -1.
So currently we run into the problem that we get sucked into the gravity well, and that's because the value we're looking at now gets so that we don't have enough speed to pull up as we reverse, so then we go down, and then it tries, and it keeps, and pretty soon you get sucked into oblivion. And that's okay. It almost is like intense gravitational force, but the problem is when we hit that bottom, we no longer are able to say, I'm on the ground, I'm no longer affected by gravity. So we're still being sucked down by gravity because we're like, okay, reverse it. Well, now apply gravity. Reverse it again, apply gravity. And we just keep getting sucked in because gravity doesn't realize we're on the ground and can stop moving. So a solution to that, for those who are troubled by that as a problem, is inside our height check, we can say, oh, and by the way, if our speed is within a certain amount, that 3 seems a little bit big. I'm going to go to a 2. So if we're small enough in our movement, so we're no longer hitting the ground quickly, that means we're right up against the ground and we don't have a lot of velocity anymore. We can say, okay, once that occurs, we'll make our speed y become 0, so we don't change anymore. And we're no longer affected by gravity. So we say the gravity of this object is now 0, so it's not going to keep changing, because these 2 lines down here, because when we reversed it, once we were down real low, we still add in gravity even though we were like on the planet's surface. And then it sucked us into that oblivion. So by adding in the lines here that specify, well, when my speed is so low and I'm right up against that edge, make the speed 0 and no longer apply gravity. And when I do that, it creates a nice quality to the animation that the object, once it slows down, and the big object, because he was moving a lot and the size of the object is big, that's why he gets killed right away, where the little object bounces and keeps going and then stops. So both of these objects now have a gravity of 0, speed y of 0, so they don't get sucked underneath our planet's surface. They're not being crushed by gravity any longer. Though that would be an interesting effect to do, is to modify the height of the object. So once you run out of speed, then you start modifying the height of the object by gravity, and you watch it progressively squish down on screen. That would be a fun challenge I would throw to some of you who are going, this is kind of neat. So when you're looking in the file, you'll notice that how you define an array. Processing's way of defining an array is, it's kind of weird. If you have used arrays in other programming languages like JavaScript or ActionScript, or processing's way of going about defining arrays is just weird. So I'm just throwing that out right now. But what we have to do when we define an array is we say what type of objects will be in that array. And the notation for arrays is always, in most languages, going to be square brackets. We've been using curly brackets, now we have to use square brackets. So we have parentheses, we have curly brackets, now we have square brackets. Deal. I mean, that's all there is to it. Just, it is. So we have the type of object that will be in the array. And then we put square brackets after that to say, oh, by the way, this thing that we're doing is an array. And it's like, oh, okay. And then we have the name that we're assigning to our array. So that's the variable name. We've been using variable names now for many weeks. Should be super scary, only a little bit frightening. So type of objects in the array, we put square brackets to say, by the way, this variable is an array. Then we have our name. Now when we go and define it, we say the name of the array is equal to, and then we use the word new. Just like when we were using our class earlier, we say new, and then this is the part that just makes me laugh. I have to once again specify the type of object going into the array, and then inside the square brackets I specify how many objects it's going to be. How many items will this array hold? So now when we look up at the notes here, setting up an array, we say the data type, square brackets, our variable name is equal to new. We reiterate the data type, and then inside square brackets we say the quantity. The quantity in the array is how many things will be in this. So arrays are just simply, think of them as a file folder or a file drawer, and you just start sticking things into it. It's just a group of objects. Now, the length of the array in processing is generally fixed. Now, within other programming languages, some have fixed type object arrays like processing. Other programming languages accept a mixed type of object. So you can put in a string and an integer and a float and a custom class, and you can put another array inside an array. So you can do whatever you want with it in some languages. But in processing, the type of object you're putting into the array is decided at the time you create that variable for it. So we hold a single data type, and the length of the array in processing is fixed. So if we say there's 1,000, there's 1,000 objects. If there's 10, there's 10 objects. There are some methods we can use in processing for making an array bigger or smaller, but it's generally discouraged. Other languages allow you to make your arrays longer and shorter on a whim whenever you need to, and they don't care. But processing likes your array to be of a single type and of a fixed length or quantity. That's how many objects will be in this. So in this example, I'm populating it with my car v2 class. My array name is cars. And for the demo, we'll just throw 1,000 objects into it. And now when you were tortured with for loops a few weeks ago, now this is why we use for loops. We use the for loop to go through all the different objects in the array. So I'm going to go back to this line in just a moment, and we'll look here. So if you realize some of you added more than 2 balls in the ball example, you had ball 2, ball 3, ball 4, ball 5, and it started to get kind of unwieldy. Using a for loop right here, I can now go through the objects in my cars array, and I can tell the first object to update and the first object to display, and then I can keep looping until I've gone through every object in my array. So that for loop right there allows me to take what was a whole bunch of car1.update, car2.update, car1 display, car2 display, and now I can just use a for loop to go through the objects in that array. So an array, think of it as a list. It's a list of objects, sequential. And the first object is accessed at position 0. So if you read the chapter in the textbook, it uses basic examples of arrays holding words or numbers and working with those. We access objects in an array by saying the name of the array, square brackets, and then the number of the object we're trying to access. In the for loop here, it is going to be starting out at 0. So the object at the 0 position in my list or array, we tell it to update and display. Then I becomes 1. Then we tell the object at the first position, second position, third position, and just keep on cycling through until we've hit the length of our array. So this kind of syntax right here, this for loop in the demo file, allows you to cycle through all of your objects in that list or array. So arrays are intimidating and scary in the beginning, but once you get used to using them, you'll wonder how you ever survived without. Cars.length is a property of the array. So we say cars, and we're asking .length, and length is how many objects are in the array. So if there's 10, it's 10. In this case, it's 1,000. So cars.length would work out to be 1,000. So I could have just typed 1,000 here and 1,000 here, but that means if I just changed how many objects I wanted, I'd have to go change it in 3 places. So it makes sense. I can say how many objects here, and then I construct that number of objects, and now I render out that number of objects. But it's a property of the array. Arrays don't have a lot of properties, but length is their primo property, because that way we can just say, hey, how many objects do you have? And it'll say, oh, I don't know, 50. And if it has 50, then we can cycle through all 50 objects in the array. And the 50 objects in the array would be at position 0 through 49. Remembering, computers are very happy counting from 0, not 1. That's what computers like to do. They like the number 0. It makes them happy. So adding the array to this file, the array is going to hold my ball object. So I say ball, and then I use my square brackets. And it really, I have a ball, and then I'm going to have balls, so I can just put that in there, just like that. So that has now said, I have a new variable. It's an array because there's square brackets, and it's going to hold objects of the type ball, or data type ball. That's what line 4 now says. Now, I can say balls is equal to new, and then I'll say ball, square bracket, and then how many. I'll just start out with 100. So 100. Now if I run this, there's no difference because I haven't populated the array. I haven't changed anything yet. All I've done is create that array object. If I run it, we'll see no difference. Anytime you start adding to a project, you work with it. Now this process that we've gone through this morning, we started with a basic sketch, organized it into functions, organized it into a class, and now we'll be adding an array and working with that. The programmers speak term to describe this is called refactoring. We're taking code that we started with and we're refactoring it to make it more efficient, more usable, more portable. It's not necessarily more concise, but it's so much more flexible that we're going to be able to do so much more with it, and that's really the goal. So refactoring is the technical term of what we've gone through this morning on this whole iteration of basic sketch into functions, into a class, and now we're going to demonstrate how we can use arrays to make a whole arsenal of balls that are exploding on screen. So now we need to populate this array. We need to put all of the different balls into the array, and for that we are going to use a for loop.
Just like what kind of with the piano.
The for loop, when I type it in Sublime, it gives me a little bit of hinting here, where it gives me the I value if I want, and because all of those are highlighted, if I wanted my for loop to use a different letter than I could, and it would change it quickly, which is nice. We'll start at 0, and while I is less than, and what we want this len to be, we need to assign a value to that, and what we want is how many objects are in the array. So it's balls.length. We will access an object in that array by specifying the name of the array, square brackets, and inside the square brackets, the position in the array. That is how we access things. It is possible in some languages that you can search through an array for an actual piece of data. So you can search through and say, go find me an object that has this value, or is this kind of object, or is this word. You can do that in some, but the array functions that we're going to work with, we will just stick to purely accessing objects in the array and then asking those objects to apply their methods, like update and display, which we'll do very shortly. So we'll say the first object in the array will be equal to a new ball, and we'll give it an X and Y position. So the position for it, I don't want them all to start at the same place, so I will give them a random X position, and I can randomly put them on screen. I could even just go with the full width of, so they go all the way across on screen. So we'll just say the width of my stage, of my window. Now, a key thing to keep in mind, and I didn't point it out earlier, notice that size is the first line that happened inside setup. That's really important that you do that first, because previously, before we throw this array mumbo jumbo in, when I said ball1 is equal to a new ball, the ball class accesses height. Height is not defined until I specify the size of my project. So a good practice to get into, and I figured this out, through trial and error. I was working on a project, and size was one of my last lines in my setup function. So I was making all these objects, and they were referencing height and width of things, and I kept getting all these weird error messages, and I was really perplexed. And then I realized they're trying to access the size before size has come into existence. So size at that point was undefined, so I got all kinds of trouble. So in your setup function, define size first. That's also why I can't right up here say ball 1 is equal to a new ball, because the ball class needs access to size. It needs access to the height and width of my document. So that's another reason why I had to define those after the size statement. And that's subtle. It's really easy to miss that. You just put in, oh yeah, I need to say size, blah, blah, blah. And you do that at the end of your setup. You don't think twice of it, and then you realize, wow, my world's exploding on me. And I'll give my random y value of 50, so they're somewhere in the top section, so they can all start dropping. Oh no, well, top half, we'll put them so they have more variation populating the screen. And then the diameter of my balls, I will give them a random amount of, a random value of 20, but I want them to show up between 10 and 30. So random of 20 gives me 0 to 20. Add 10, that gives me 10 to 30. Now it is possible I can do 10, 30 with random in processing. I'm just not in the habit of doing so, because in the other languages that I work with, that's not allowed. So I'm used to doing it this way. But if you prefer, we could go like this. So we can do that. So that now creates a new ball. Ball 1 and 2. I don't want those anymore. Get rid of those. And now it's just going to be use my for loop again. Access it by name of the array, square brackets. Have the ball update itself. Display itself. So now I have 100 balls. I'm using for loop to create. I'm using a for loop to control their movement and display. And if all has gone well with the universe, when I run this, I won't get any nasty error messages. And looks like got a little issue in terms of my x value. If you notice what happened there, and I'm laughing at myself at the moment, I said set their x position equal to the width. That means all the way over to the width, and they're all now showing up on the right-hand side of the screen. So as I said, if all has gone right with the universe, apparently things weren't quite there. We need to say a random value that varies along the width. And if I don't want it to be exactly the width, I could do something like 10 or say 30 comma with minus 30. So there's margins, so I don't have any that are going right down the sides there. So now if I try and run it again, let's see, get the bouncing balls until they all succumb to the effects of gravity. And eventually stick on the bottom. And if I get rid of the parts that I no longer need, you will notice that it's a much tidier, there's fewer lines of code, and I'm doing more with it.